Hello everyone. So today's problem is course schedule 4. We are given here is there are total number of num courses you have to take leveled from 0 to n minus 1, and you are given a prerequisite where prerequisite of A of I and B of I indicates that you must take course A of I first if you want to take course B. For example, the pair 0 1 indicates that you have to take course 0 before you can take course 1. Prerequisite Prerequisites can also be indirect if course A is a prerequisite of course B, okay, and course B is a prerequisite of course C. So what it means is like we are given some courses, like let's say 0 to 1. Let's say there are multiple courses. Let's see here. Okay, so let's say for now we are having some courses 1 and 2 and another course 3. Okay, so what they're saying is like there is some prerequisites array. So what does this define? Let's say we have 1 and 2 here, which means that for completing the course 2 you need to take course 1, right? And similarly, like let's say there is this path, okay, like for completing course 3, you need to completing course 3, you need to complete course 2. Okay. So what happens in this case? Like for completing 3, we need to take 2, but for 2, we need to take 1. So initially we need to take course 1, then course 2, and then course 3. What does this show? Like this shows that we need to create a graph here. Okay, it's a graph problem because you can see here like this prerequisites here represents the connectivity of the graph. Okay, so in shorter terms, they have given a number of courses. Let's say it is 3. It represents that we have 3 courses, some course A, course B, and course C. Let's number it 1, 2, and 3 for simpler method. Let's say 0, 1, and 2, and we are given some prerequisites array. Okay, this array represents that take course we need to take course 0 in order to take course 1. Okay, and there is some query. So what does this query ask? Like this query ask is if if we can take if we need to take course, let's say course 2, in order to complete 1. So let's say we this prerequisites create this kind of graph. Okay, and we need to take course 1. So for course 1 we need to take 0, not 2. So the answer for this query will be false. In that place, if there would be a 0, 1 scenario where we need to take course 1 and we need to check if we need to take a 0. So we need to take 0 in order to complete 1. So the answer for this will be true. Okay. So how are we going to approach it? Okay. So we will be approaching it with a path, like if there exists a path, let's say we have a graph 1, 2, 3, and 4. Okay. And let's say we need to complete 1. For taking course 2 and 3, we need to complete course 1. And to complete course 4, we need to complete course 2. Okay. So what they're asking is if course 3 is required to complete 4. Okay. So the condition here will be false, right? So, how do we approach it? We simply need to check if there exists a path between this prerequisite and the destination, right? So, does is there for 3 and 4, there does not exist a path because this is a directed graph right? Directed graphs. And uh, there does not exist any path from 3 to 4. Like 3 only has one incoming node and no outgoing, so it cannot reach 4. Okay, but let's say if we give here 1 and 4, so there exists a path from 1 to 4, like we go from 1 to 2 to 4. Okay, now see, this is a simple DFS. We can also solve, yeah, it's our DFS only, right? Because first we take a node, we explore its nodes, neighboring nodes, and we choose one of the node. Let's say we choose here 2, and then we go to its depth. Okay, and let me remind you, like DFS works on a stack basis. Okay, so like first come and last sum. Okay, so let's say if we put a 4 here or a 2 here, so if a 2 is inserted last, it will pop out first. Okay, now how will we g- approach it? Okay, first we need to create a courses map. So what this courses map is, okay, like for what course we need, for what course there are prerequisites. Okay, so let's create an empty map here. Let's say a course map, and what we can create an empty here, like 0 and a list here for I in range. Oops, let's create a map first, right? Map. Okay. It's called as adjacency matrix, adjacency map, or neighbor map, anything you would like to call. So we will create I, and I as a key and its requisites as a list. And for I in range, it will be the number of courses, right? So this will give prerequisites, let's say for here, let's say for 0, we have a prerequisite of 1, right? So what we'll do is for let's say for m comma n in, what do we have? We have prerequisites. Let me copy this, too long. Yeah, prerequisites. We will create a map of, yeah, we'll create a map of m, and we'll add it to and n. Right. So for, let's say if we have 1 0 here, so 1 is directly connected to 0. Okay. And let's say this is our RES. RES is like where we will store results. And what we will do is we will first go through our queries. Let's say for x comma y in queries, right? And we'll simply append the result here. Now, what do we need to append? We will check like there exists a path from x to y. Let's say if there exists a path from x to y. So this could be an indirect path. Let's say there is a variable, let's say a node a and another y. So this is a valid path, right? So that's what we are going to check. Now we need to create a def first search traversal function. Let's say we will name it traverse, and we have some prerequisite here and a destination node, right? And what we'll check, like if our prerequisite is equal to our destination. Okay. Now what we'll do, we'll return true here. Now what we'll do, like let's say this pre is not equal to our destination. So what do we need to do? We need to go through this map. Let's create a map here for ease. Okay, and let's say we have a good example. Yeah, this is a good example. Let's say we have this. Okay, and so what we are creating a map for. Let's say we have a map here, one, and its list has two, right? And then again one, and then it list has zero. So for taking code zero, the prerequisite is one. Okay, and in our first loop, we are looping through these. Let's say there are just two, three, and some other nodes. Okay, so we are first going through this loop. So that's why this is our first loop. Now, uh, once we go through this, we need to go to depth of each of the neighboring node. So that's why we are going to do a for loop for items in what is our uh, what are our neighbors? Okay, so map and oh, we will go through our pre. What is pre? Pre is a prerequisite. This is prerequisite, and these are the nodes. So we have now we will traverse through this list, the neighboring items. Now we will check like if again traverse of items, comma destination. So if it is true, return true. Okay. And at the end we will return false. And what we will add here, arrays.append traverse of x, comma 1. Okay. So and that's it for the program. Now there is this one thing I would like to add. Okay. So if I add, oops, okay, if I add a cache here, what does cache mean? Cache is a simple storing mechanism. It's like creating a hash map. Okay, so why I'm creating a hash map? Uh, what's a cache? Okay, so cache is like it's like a repeated integer. Let's say we have some kind of function f of x comma y, and for a particular set of values, let's say for one or one comma two x or y, it will always return some kind of value, and let's say 3 comma 4 x and y, it will always return some kind of value. So uh, we don't need to proceed further code. Okay, we don't need to execute this code. We can directly return this and this. Okay, like for one and two, we will directly return A. No need to process this thing, these many lines of code. So it's a part of dynamic programming. Okay, now yeah. So that's the work of cache. Now why cache is required? So let's say we have this path one, two, 3 and 4. Yeah, it's a directed graph. Okay. And let's say we have a query for 1 comma 3 and we have a query for 1 comma 4, right? So they for first time we will traverse this whole path. Now for this whole path, oops, sorry, not this one, 1 comma 3, right? So this path when we traverse for 1 comma 3 we have a true value, right? And then for 1 comma 4 there will be an instance the uh, where the this node will be 1 comma 3. So 1 comma 3 is true, and this is if we are reaching from 3 to 4, then this should be also true. Okay. So that's why we are adding a cache here. And when we run through it, okay, traverser, Okay, strange. Okay, so there must be some kind of mistake I made, or yeah, and okay. We will submit, and yes, it's working. So, yeah, thank you everyone. Hope you liked the video.